let's start the Upstreaming 201. Sorry, just now I have give the question and answer the time for you guys. So if you have any question, just let me know. And for this session, they also very quite depend on for the example driving. So if they have any question, just bring up. Yeah.
About being, you said good to have patience. So how many actually maintainer uses patchworks so you can see what's the status of the patch? How many percentage?
How many percentage of what?
Of maintainer uses patchwork.
You mean if they send out 100 patch, there how many send patch?
No, there is a tool called Patchworks, where you can see the status of each maintainer. How many maintainer use this?
Okay, sorry.
Very few, and also even for the maintainers who use it, it's not going to give you an answer any faster. Usually they're not going to update the status until they review things. But yeah, it's very few. It's networking is a big subsystem that uses it, and the video people use it, but it's uncommon.
Yes. So for the overview in this session is built on the Upstreaming 101. In this session is example driving. We were to see the subjects and commits messages firstly, and we are to see they have examples for the responding to comments, and then later we are to see two examples. One is for upstreaming a new platform, and finally we are to see the example for upstreaming a new driver. So treat this session like a workshop. So if you have any question, just to ask. So when we send the patch for the subjects in the documentation submitting patch, they have very detailed explanation for how you write a good subjects. So because when later when your patch has been merged into the Linux kernel mainline, then later there have other guys wanted to discuss your patch, they will to use your subjects. And also if you want to search one specific patch, you can use the git log 19. So you can search the specific patch with the subjects. So subjects is quite important because usually some guys want to search related patches. Even in the Google, they can easily to get searched patch if you have good subjects. So for the subjects, the summary phrase must be no more than 70 or 75 characters, and it must describe both the patch changes as well as why the patch might be necessary. The subjects have multiple parts. The first part is in the square bracket, they have patch and a tag, and also later following the summary phrase. So for the tag, you can indicate the number for the comments, for the version of the comment, for the version of the patches, because you have some response to the comments. And also you can use the RFC, or you can use the number like the 104, 204. For the commits, commits will be very useful for the later people who also, for example, find the similar issues or failures. So if they want to search the building log, failure log, or the errors, so if you have a good commits, then it can be very easy to search from the commits to get to know which patch has been fixed this similar issue. So here is advice on style for the commit messages. Here is one example is that in this patch, the author said he write this patch because we want to calculate the blinks per second, and instead of making it 5, let's make it 4, so the user can see how to can see 2 blinks per second. So we can see in these commit messages, it's just to tell what is patch for, but it don't explain how the patch works, what's the current issues it faced. So Ingamolo provided the suggestion to use the customary changelog style. So use the pattern is like current code does A, this has a problem when B. We can improve this doing C because D. So use this pattern, we can very easily to follow up what's the current issues, how this patch is doing, why is it doing like this way. So here is a good example for the summary and the commit messages. We can see in this subject, it has used the multi-part. First is patch in the square bracket, and then because this patch is to modify for the max DTS, so first it will to indicate it's in the ARM, this architecture, and it will to change the code in the DTS, and then it will to change the code in the platform for the MX. So finally, is the summary phrase to describe what the patch to do is to do for the SDHC port. And then in the commit messages, it will to explain why this patch to do. So it will to use, otherwise the MMC driver will operate with the default bus width value of 4. So it will describe the current issues, and then he will to also give the final solution to change it to 8-bit wide. Here I have one example is don't ignore comments. So I see that there have many situations is the developer, they don't respond actively to the comments. There have several different reasons. Some reason is that the developer don't really understand where for the comments come from the maintainer or review. Another reason maybe is the developer dislike the comments, so they ignore the comments. Either way, this shouldn't happen because usually you can see in this case, the developer sent the patch, and then in the first version, the Mark Brown gave the comments, but to refine the DT binding for the regulator, so you can use the most simple way for the DT binding for the regulator. But the developer ignored this in the version 2. So Mark Brown to repaste the comments again in this thread. So don't ignore the comments. And if sometimes you don't get clear what's the comments meaning, so you need to ask the question to ask the maintainer to clarify the comments. So you can see here is a good example is the developer asks the question is I'm not quite following this. So he have some guessing for the meaning from the comments, and then he asks, can you explain more for this? So the maintainers in this case will give more detailed explanation for the comments. Incorporating comments, sometimes when you get the comments, if you think you want to acknowledge it to these comments, you want to fix it in your next version patch, so you can just to reply simply, say, we're fixed. So that means that you have acknowledge these comments, and you will to add the change in your next version's patches. Here I have one example is I think this is one case that we don't do this is if there have any discussing, and because this discussing may be introduce very huge regression for your works. So some people, they launch a personal attack to the review. So actually, if you use this way, there have no where to distract from the technical discussing. Then maybe there have many discussing focus on this personal attack. Then this will be not help you for your upstream, your color patch. So you only don't do this way. Another thing is that you only when we upstream the patches, there have many comments. Basically, I think these comments is come from the maintainers. They have very much experience on this area. So they have did many works or the homework on this area. So basically, you should to think about if really these comments is technical comments or is not. Understanding arm-soc, because usually our most work is for arm-soc. So if we understand arm-soc, we can get to know how to divide our patches into logic division. So divided patches going to arm-soc, they were to go into different topic branches. So there have one topic branch, for example, for the fix. So this branch just to merge the bug fix patches, and for the cleanup branches for the cleanup patches, and there have the SOC patches and the driver patches. Usually the driver patches will be merged into the subsystem maintainer, but not from the arm-soc maintainer. So, but sometimes there have some sync between the arm-soc maintainer and the subsystem maintainer. So if the subsystem maintainer agree this patch can be merged into from the arm-soc maintainer, then the arm-soc maintainer will to merge the patch in the next drivers, this branch. And because for the ARM, there have one SOC, maybe it can support different boards. So there also have the branch to support different boards branch. And the next one is for the DT. So if you have any change for the DTS file, there is some entry to support new drivers. So there have renit patch will be merged into next DT. So this category is very important for the platform maintainer because they need to know this division and they will to prepare their own repository at these branches, and they will to send out the pull request to the arm-soc maintainers. So, but this is also very useful for the individual contributors. So everyone, if you write your patch, you should to get to know here have different categories, and you will to divide your patch in fit these categories. There have a very detailed presentation which is delivered by the Johansson. He is the Google's developer. He is also the arm-soc maintainer. So he delivered very detailed presentation. You can get the linkage from here. So when we want to upstreaming a new platform, for example, SOC full, then we need to logically to split the work into the mark full. This folder where to place, for example, the board or the SOC related files in this folder. And there also have the clock source driver. For example, for the you have a SOC they have timer, and this timer will to provide the clock event to the CPU, so they have clock source driver. And the IQ controller driver, because this is a next implementation. For example, there have some SoC vendors, they don't use the GIC, they use their own interrupt controller, so maybe they have dedicated interrupt controller driver. And for the device tree binding, this is documentation. If you want to upstream your new platform, they have new device tree binding for the compatible string or for the property, then you should have the documentation. And when you enable the platform, you can have two choices. One is use the V7 DF configure. So they use this DF configure, it can support multiple SoC in one image. Or you can create your own DF config by only for yourself SoC. Finally, you can enable the device driver in the DTS to enable the platform full. So we can see if you upstream this code, the maintainers also, they will to split into divide amongst the maintainer tree. So for example, for the clock source, the driver, it will be merged into the clock source subsystem. And for the IQ controller driver, it will be merged into the driver interrupt the folders by the interrupt maintainer. And if they have the other patches will be merged from the ARM SoC, but these patches also will be split to divide according to ARM SoC categories. Now, for ARMv8, they have a big change. Because for ARMv7, every SoC vendors, they can create their own folder in the ARM, Mac, for example, Broadcom or PXA for before X-Gears serials. But now for ARMv8, every SoC vendors, you cannot to commit any SoC related patches into the ARM64, these folders. In this folder, they only have the code for the ARM architecture release code. So for all the SoC vendors, they only can provide the patch to the driver subfolders. So this is quite like the children's toy Lego. You can combine the CPU or the interrupt controller, or they have several peripherals in the DTS. So in this way, you can describe what's your SoC component and what's the component in your board platform. So for ARM8, you cannot upstream for the Mac full, this folder, but you need to provide upstream for the clock source driver. This also is very tricky, not necessary for ARM8, because now for ARM8, they have the archtimer can be used by the CPU. But if you want to enable the CPU idle, this no power state, you should to enable your clock driver from the SoC level. And for device tree binding, there usually maybe you have some yard or some clock. You maybe were to introduce some new DT binding. So there will have patched for the DT binding. In the ARMv8, there only have one DF configure. So there have no more, you cannot create your own DF configure for your SoC. DTS, so actually now almost all the platform maintainers work now is to enable the DTS. So we can see in ARMv8, every platform they have where to maintain the DTS for themselves SoC. This also need to split these patches, divide amongst the maintainers tree, also need to split to divide according to ARM SoC categories. So here is an example for the upstreaming ARM SoC. Here is the coordinator. In this coordinator, it explains that the all winners SoC is A10 and A13, but the SoC is internal code name is SUN4I and SUN5I. So finally, they named the mark this director as SUNXI. Here you can see when they upstream the patch, they also give some very brief introduction for the roadmap for their latest work. For example, they see in this patch series, they just support a very quite minimal for law for include timer and IQ controller. But later they were to support more peripherals, were to submit more other patches. So when the patch has been submitted to the mailing list, they get some back some comments. The comments is that you should define the macro for the debugging port for UART. So you can use this way to support only not use the UART1. Also, maybe it can be helpful later to extend to support UART0 as the only print key debugging console. So this is the comments from the mailing list. Then the developer, he gave very quickly fix for that, and he sent out the version 2 for this patch series. So you can see this is in the patch 2's cover letter. So in this cover letter, he explained that they have the change from version 1. So you can see here, he described that he changed the only print key support to only not use UART1, also can both the debug UART on UART0 or UART1. So this is some have change log compared to the first version's patches. So after the change, then it will very quickly be accepted by the arm-soc maintainer Art. So Art said that it looks all great. So they have some discussing how to merge this patch. One method is the maximum. He can send out a git pull request so that Art can directly to maintain to merge these related patches. Another method is that Art can handle this patch, can manually to merge this patch into his repository. So Maxim, he just to create a git pull and send out again. So it will be helpful for Art to directly to merge this code series, patch series into arm-soc's repository. This is an example for upstreaming a driver for the watchdog. For the watchdog driver, it will be logically split the work. The first patch is for the DY tree binding patch. So this will be merged by the DT team, or also can be merged by the subsystem maintainer. And if there have any changes for the framework, for example, if there have any bug fixing for the framework, or there also have some patches to add a new API for the watchdog framework, then this will be some patch for this. And then it will be a standalone patch to enable the driver and for the built-in plumbing. So you have some change for the key configure and for the make menu, make file. So can use this patch. Then you can enable the built-in for this driver in the DF configure. So finally, they have the patch for the DTS edition to enable this driver. So you should to use the logical split split your patch into these several categories. So these patches will first be divided amongst the maintainers tree. So some patches maybe will be merged from the DT maintainer, and some patches will be merged by the platform maintainer or arm-soc maintainer. And then for the subsystem maintainer, it will to divide the patches to framework updates, specific driver features, and the individual bug fix. So also they have different categories for the subsystem maintainers repository. So here is the example if you want to upstream, is the example for Broadcom, they upstream for the watchdog driver. So one is used a very simple way. They just do upstream for the watchdog driver, and another patch is for the watchdog enabling in the DF config. They also have another way that if you have a new device tree binding, you should to use the first patch to add the document for the DT binding, and then there have the watchdog driver and the configuration, add the configuration patches, and finally the patch is add the DTS entry to enable the watchdog driver. Actually, I think now usually we use the second method because now the device tree maintainers, they ask if you want to use the device tree binding, you must to first need to document the device tree binding as the first patch. So usually for the new DT binding, the compatible string, it will be used in the second patch in the watchdog driver. So when they review the watchdog driver, they have new device tree binding compatible string. Then they will to ask you if they have the documentation for this. If you haven't, then they will to reject that. So when you want to generate the patch serials, you can use the command git format patch. So what we want is we want to generate the patch serials. It's not only one patch, they have several patches. So also because we want to generate one cover letter, so the 0 of 2, this patch will be the watchdog's cover letter. It will to describe the whole story for your patch serials. So you can use the command git format patch cover letter and output the patch serials into a specified folder. Here you also can specify the mail address into the 2.9 or in the CC9. So you can use this way to generate the patch. And the next parameters is the commit log. You want to generate a patch from which commit log to the latest patch. So use this range you can generate the patch serials. So as a result, it will be in the folder, have 3 patches. The first one is the cover letter patch, and the second and third one is the real patches for the drivers. So in the cover letter, actually when you open it, it's empty. You need to write the cover letter by yourself. So you need to write the subject for the cover letter. You will to describe what's the subsystem and what's the patch series doing what thing. And then in the cover letter, you need to describe very detailed information for what this driver series is doing. Actually, for this case, it's quite simple because it's just enable the watchdog. So it uses very simple, clean the description here. But if for some case, it's very complex, so maybe you should to describe what's the current issues the patch you want to fix, and what the patch is doing, how it's doing. And finally, sometimes you also need to give some testing results on the coordinator. So there will be a whole story for the patch series submitting. This is the commit logs message in the watchdog driver. So, but actually this is also very simple. You can see, just said this patch where to add support for the watchdog timer used by the Broadcom, the family of SoCs. But here I have one thing we can know that every other of the patch they were to 8 to 9 of the sign off by. So this way we can see this is signature for every developer. So when you send out the patch, you must to add the line to sign your name. Also because there maybe have some maintainer or some other developer have reviewed your patch, you can add the line reviewed by. So this way can get to know this maintainer or this developer he has reviewed this patch. Also, sometimes we also can add a line, for example, CC to somebody or to somebody. So this way, when you send out the patch, this patch will be automatically to send to some the related the persons. Here is this driver have get some comments for the initialization. So you can see here have some comments from for the return value. So because there also have another comments also for this part code. So when you reply for these comments, it said I will change that based on another developer and your comments. So this way to give incorporate comments and return back, make sure that the next time you will to fix this part. So we can see in the next version 2, they have changed log since the version 1. Here also they have changed log that it have the synchronized secure regulation rate to return timeout. So this way to indicate that he have fixed the comments in the version 1. Here have then there also have several iterations. Then it's the version 5. This driver finally will be merged into the watchdog subsystem. But for the maintainer, he applied this patch only one part of this patch because he have removed the debug this related code. So he gave the comments that I applied the patch, but without the debug part. So he manually removed the debug part. So for some cases that if you want to merge the patch very quickly, you should to keep the driver as simple as possible. So that means that it will help you to easily get the patch to be merged. Then later you can send more patches to enhance your driver step by step. So in this case, it's just to finally to remove the debug part and use a very simple way to merge the patch. So when you send out the patch, you can use the git maintainer, this per script, to get the related the maintainer or the developers. So there have one parameter is -if. Use this parameter, you can get to know one specifies this files, what's its maintainer, who is its maintainer, and who is this files orders. So you can use this way, you can get to know if you want to change the code in this file, you can send which developer and which maintainer to them. Usually I use the method is just to generate the patch, and then I use the script get maintainer to and input the patch name. Then the script will to automatically to print out the maintainer's name and email address. It also will to print out the mailing list in the next part. So you can use this way to add the maintainer and add the mailing list to send out the email with this address. Okay, so that's all. Have any question? Okay. These slides have not been uploaded, but later this slide will be uploaded, so you can download the slides from the possible the website. Okay. Thanks. Thanks.